Like many men, I'm self-conscious about the tools I'm working with. So I was going to solve that by making a milling machine. As a baller on a budget, I decided to make my own, which was my first mistake. Making it out of wood was my second mistake. For my first step, I used every clamp I had in the shop in order to glue together some 6x2s in order to make a wooden base, which wasn't nearly flat enough. So I flattened it. After flattening, it was good enough for who it was for, so I continued. I made a wooden sandwich by sandwiching the lumber I just flattened in between two pieces of 3/4 inch plywood to reduce warping as much as possible. The wooden sandwich base wasn't as flat as I needed it to be, so I flattened it. So I have the slab on the flattening table, but it's too tall for the sled currently. I'll have to replace this wooden spacer, make it about 1.25 inches taller, so that this screw will actually clear the top of the sled. I made 4 shims to hold up the 4 points of the router gantry, and they definitely all worked the first time I made them. Now I need to figure out how to connect these to the base. I glued the 4 posts together and then drilled holes in the base for mounting the posts to the base. Using the 4 holes in the base as a reference, I drilled the 4 posts and installed the leg screws. The impact wasn't strong enough, so I had to use a ratchet in order to drive in the leg screws. Then I started doing some weird stuff of cutting random boards and stacking them on top of the 4 posts. The base is made. I have to attach the part that will actually hold the head of the mill, the Z-axis. So I just have a bunch of pieces of wood, but I think I'll wait to attach everything until I can reference it to the X and Y axes to make sure that the head is properly trimmed. Then my ADHD kicked in, and I was cutting the aluminum and the plywood for the sleds for the mill. Well, this sucks. I need this router bit to sit a lot lower on the piece of wood. Right now it's taking way too deep of a cut. So with the table saw, I just cut a somewhat square hole that is supposed to be able to fit a 1/2 inch threaded rod, and sadly it does not go in. So I get to keep cutting away. After recutting with the table saw, the threaded rod actually fits in as it should. The next mission was to glue a 1/2 inch 20 nut into the sled to drive the sled, and I did this by drilling it out using a jig I made. I started work cutting plywood, making the rails to guide the sleds. But then my ADHD kicked back in, and I decided to mount the additional boards on top of the 4 posts, and these will hold the Z-axis in the future. And I started gluing a bunch of random boards together to build up the Z-axis. Once the nuts were epoxied in place, I wanted to test how the sleds moved with a drill. I decided to flatten all 3 sleds but I ran into another issue with the size of spacer I had. I decided to thread a 4-inch long quarter 20 bolt so that I wouldn't have to change bolts every time I had to change shims, which means the cheap Amazon tap and die set lives another day. I began work shaping the rails. The rails needed a dovetail cut in them, which is an angled face for the way this mill will work. One rail will get an aluminum piece to act as a wear surface and to help distribute the force that the Gibbs system will be exerting onto the sled. And the reason I need an adjustable Gibbs system is to help improve rigidity on this machine. Since it's made out of wood, I imagine it will need all the help it can get. The dovetail shape I just cut into the rail and into the sled was perfect. So perfect, I decided to cut it again. With the dovetail fit being more better than it was time to glue the aluminum onto the rails. Then it was time to mount the rails to the base. I like to start connecting two pieces with hot glue. That way when I drill a pilot hole for a fastener, I know the two pieces will not move apart. The X-axis sled was the exact same height as the two rails, and I didn't like that since the Y-axis rail could scrape and cause friction. So I solved this by trimming down the two rails that are supposed to pin down the sled. And in even more infinite wisdom, this caused both rails to be too short, and that would make me have to cut the angle a little bit deeper in order to fit the gib and the sled properly. Now that I have a mile of clearance between both rails and the sled, I will continue to install the rails with the gib in place. The two aluminum skis that go underneath the sled are there to help reduce friction, and me, in my infinite wisdom, did not install them before installing the rails. To make the Y-axis rail system, I started by flattening some plywood that would hold the Y-axis rails. I added a 3D printed square since I didn't trust any of my squares. Then I started connecting everything together with hot glue before coming in with some screws. I was fortunate that I had a drill bit long enough to go from the top of the rail all the way down to the X-axis sled. Once the first Y-axis rail was fully screwed in, I put the sled in and used the sled to determine where the second rail position is. Once all the screws were installed, I glued the aluminum skis onto the Y-axis. Once the Y-axis was all put together, I drilled pilot holes into the Y-axis so that screws can be installed to push against the gib, and the gib would push against the sled and increase friction and rigidity when trying to move the axis and during milling operations. I did the same thing on the X-axis. When I was happy with the X and Y axes, I started work on the Z-axis. I began by hot gluing all of the pieces together and then adding some screws. Once the first rail was completely screwed in, I added the two aluminum skis, the gib, and the additional rail, and I went ahead and hot glued everything together and then screwed it all together. After the skis were epoxied on, I began work on a back brace for the Z-axis, so the Z-axis can stay rigid once it's mounted. I 3D printed the part that holds the router and began mounting it to the Z-axis. I had to remove a rail and ran into another problem. One screw snapped off, and I had to perform some quick surgery with a grinder. After that, I had the grand idea to glue all rails to all axes, which meant I had to take apart almost all the work I just did. In order to tram the Z-axis, I connected the router holder to a pillar that was connected to the y-axis sled. After that, I ran into another issue. Some genius made the base way too wide, and there wasn't room for a handle. So I had to drill and tap the threaded rod so that I could attach a handle with some hardware. And this was another win for the Amazon tap and die set. The threaded rods needed something to push off of, so I added supports on the X and Y axes and then attached some handles. And then I took it for a test run. I was pretty happy with the progress. My half-baked idea is quickly turning into a three-quarter baked idea, so I continued work on the Z-axis. I spent a lot of time and went slow and did my best to connect the Z-axis without moving it once it was locked in place. I think all of this was a waste of time since I ended up messing up the alignment later on. I was getting pretty excited to use this, so I made the simplest handle I could, and then tried to mount the vise to the y-axis sled, and I couldn't. I had to prop it up with a piece of wood, and then we were off to the races. I trimmed in the vise with a dial indicator and corrected it, and then I put in my first test block, which is a piece of wood. So this isn't good. When I tighten on this nut, it applies pressure on the 3D print, which of course is printed in the wrong orientation so that it splits really easily in this direction. And I got the same thing going on over here. I redesigned the bearing housings with a split in the middle so that the wood screws will take more load. I did a small test on an aluminum block, and the router did quite well. And that's a pretty cut in aluminum. I did a small test on a piece of steel. The bit had a lot of chatter to it, and it was a lot noisier compared to the aluminum block. Overall, I'm very happy with the way this milling machine turned out. I don't think I would use it for production parts, but it's still a very handy tool to have. Just like that, after a week's of work, I have a baller milling machine for under $200.